Imagine this. For months, Voyager 1, a spacecraft older than the Internet itself, had gone completely silent. 15 billion miles from Earth, drifting in the endless night between the stars, its voice vanished. No signal. No data. Just silence. A silence so deep, so absolute, it felt as though the universe itself had drawn a curtain over its oldest traveler. Scientists feared the worst. Had humanity's farthest emissary finally died in the dark? Had the last whisper from our cosmic scout already faded forever into nothingness? And then, just as hope was beginning to dim, a faint signal returned. But it wasn't the normal stream of engineering updates or the predictable hum of background data. What Voyager 1 sent back cracked open one of the oldest illusions we had always clung to. The idea that the void beyond the sun was truly empty. Because what Voyager revealed wasn't a void at all. It was structure. It was movement. It was pressure. It was boundaries. It had reached the other side of the sun's protective bubble, and what it found there was nothing like anyone had imagined. When Voyager 1 crossed the heliopause in 2012, it became the first human-made object to leave the sun's shield behind. Many assumed that beyond this frontier lay only silence, an infinite stillness of scattered particles and faint starlight. The heliosphere, after all, was believed to fade gradually into interstellar space like a shoreline slipping into the sea. But Voyager proved this assumption spectacularly wrong. And in April 2024, after months of corrupted transmissions, the spacecraft reawakened and began sending back data that shook the very foundations of astrophysics. Out there beyond the heliopause, space is not quiet. It hums. A low-frequency oscillation, steady and persistent, fills the void like the heartbeat of some unseen giant. Voyager's plasma wave instrument detected this cosmic hum, a background energy that seems to ripple across the interstellar medium. Scientists had long suspected something like this might exist, but hearing it directly was different. It was no longer theory. It was real. And it wasn't only the hum. Voyager also measured sudden density spikes, bursts of plasma pressure that felt like shockwaves frozen in time. These may be the lingering scars of ancient supernovae, massive stellar explosions that once tore across the galaxy thousands or even millions of years ago. It was as though Voyager was passing through a cosmic graveyard, crossing invisible boundaries where the deaths of long-forgotten stars had left their mark. Far from being an empty corridor, interstellar space appeared more like an ocean, swirling with unseen currents and echoes of past cataclysms. And Voyager, small and fragile, was our little sailboat drifting blind through a stormy sea we had never even known was there. As it pushed deeper, Voyager's instruments began to reveal a picture no telescope could capture. Its magnetometer recorded sharp distortions in the galactic magnetic field, places where the sun's field twisted violently against the galaxies, grinding together like tectonic plates colliding beneath Earth's crust. These weren't random fluctuations. They were patterned, structured, perhaps even organized. Some researchers now believe the galaxy itself may have a kind of magnetic skeleton, vast filaments of force shaping where matter flows and where it doesn't. Certain regions deflect cosmic rays, while others seem to funnel them into streams, rivers of radiation winding unseen through the darkness. One of the most startling discoveries was Voyager's crossing of such a threshold. Suddenly, the probe detected a sharp spike in high-energy particles, accelerated by distant supernovae and black holes, slamming into its instruments at nearly the speed of light. These weren't gradual changes. They were abrupt, like stepping off a cliff. Voyager showed us that the edge of the heliosphere isn't a soft boundary. It's a wall. And beyond that wall, the rules are different. But even getting this information was nearly impossible. In late 2023, it seemed the Voyager mission had ended. The spacecraft's signals were garbled, its systems unresponsive, its memory corrupted. Most likely struck by a stray cosmic ray, the very thing it was out there to study. For most machines, this would have been the end. But NASA's engineers refused to give up. From 15 billion miles away, with commands taking 22 hours just to arrive, they attempted something audacious: rerouting Voyager's software into backup memory hardware, technology built nearly half a century ago. It was like performing delicate brain surgery through a time machine using tools older than the surgeons themselves. And somehow, it worked. By April 2024, Voyager was alive again. First came the engineering signals, then the magnetometer data, then the plasma and cosmic ray detectors. One by one, its instruments reawakened, and with each step, humanity's window into interstellar space widened. Voyager wasn't merely restored. It was reborn. What it sends back now is more than raw numbers. It's a kind of blueprint, a living map of interstellar space. Using its data, scientists are charting the first interstellar navigation guide, not of planets or moons, but of radiation zones, magnetic boundaries, and plasma cloudlets. Already, Voyager has passed through at least 2 distinct interstellar clouds, regions of denser gas and plasma that behave like invisible fog banks. Each one had different temperatures, pressures, and magnetic alignments, as though Voyager were crossing invisible continents. Someday, these maps could guide future astronauts safely through interstellar corridors, shielding themselves behind magnetic ridges or dodging the deadliest cosmic rays. But Voyager's data may hold an even deeper truth. Some astrophysicists think these structures, the filaments, boundaries, and pressure zones, could explain how stars are born. The way they funnel material may be the very mechanism by which gravity assembles raw gas into newborn suns. Voyager, in this sense, isn't just an explorer. It's a cartographer of creation, sketching the hidden anatomy of the galaxy itself. For decades, scientists thought interstellar space was uniform, particles randomly scattered across millions of light years. Voyager is proving otherwise. Instead, it's like an atmosphere filled with interstellar weather, temperature changes, density fluctuations, and currents of charged particles. Voyager has flown through sudden plasma shocks, low-frequency hums, and pockets of high radiation. Some regions even seem to carry echoes of supernovae, magnetic shockwaves still rippling outward long after the stars that created them have died. These discoveries are transforming our mental image of the galaxy from a static star map into a living, breathing system. One of the most profound revelations comes from Voyager's crossing of the local bubble, a vast cavity spanning hundreds of light years, likely carved out by multiple supernovae millions of years ago. Voyager's instruments are now brushing against its distorted edges, zones where the magnetic field bends, where plasma densities change sharply, and where cosmic rays seem to pile up like driftwood against a shore. These aren't just random anomalies. They are the scars of violent cosmic history, the lingering evidence of titanic explosions that shaped the very environment in which our solar system now floats. And then there is the sound. Voyager's plasma wave detectors record something eerie, continuous low-frequency oscillations that fill the silence of interstellar space. These aren't ordinary radio emissions, nor the faint cosmic microwave background. They are steady vibrations, like the resonance of the galaxy itself. Some scientists describe it as a hum, others as a heartbeat. It shifts slightly as Voyager moves, as if the spacecraft were moving through zones of resonance, crossing invisible strings of a galactic instrument. Is this the natural resonance of plasma interacting with magnetic fields? Or is it something stranger, something we don't yet have words to describe? Whatever it is, Voyager is moving through it now, and for the first time, humanity is listening to the song of interstellar space. Each measurement Voyager sends back is a kind of landmark, a magnetic ridge here, a spike in cosmic rays there. These are not just anomalies. They are the beginnings of the first topography of interstellar space. Imagine maps of invisible mountains of radiation, valleys of low-density plasma, or ridges left behind by ancient stellar deaths. This is what Voyager is creating, a landscape of the unseen. These features are not only hazards, they may also be highways. Natural corridors of lower radiation could one day serve as safe routes for interstellar probes or even human travelers. Voyager 1 was never meant to last this long. It wasn't built to study interstellar space. It was designed in the 1970s to explore Jupiter and Saturn, to give us our first close-up look at the gas giants. Everything since then has been a miracle of endurance. And yet here it is, still alive, still whispering, still rewriting what we thought we knew. What Voyager has revealed isn't science fiction. It's something more unsettling, more awe-inspiring. It has shown us that our solar system is a fragile oasis, shielded by the heliosphere, cradled within magnetic boundaries, and surrounded by a galactic sea far more dynamic and violent than we ever imagined. Out there, space is not empty. It is alive with echoes of stellar death, rippling with magnetic turbulence, humming with hidden energy. Every pulse Voyager hears, every filament it maps, every variation it records is building toward one truth. The galaxy is not a static backdrop of stars. It is a living, breathing environment, and we are only beginning to read its story. And so, as Voyager drifts further into the unknown, carrying with it the golden record, a message from humanity etched into copper and gold, it reminds us of something essential. That exploration is not about reaching a destination. It's about listening. Listening to the universe whisper, and daring to follow its voice. So the next time you look up at the night sky and see nothing but pinpricks of light, remember this. 15 billion miles away, an aging spacecraft still drifts, still listens, still transmits. Against all odds, it is mapping the unseen bones of the galaxy. And perhaps, in its quiet way, it is reminding us that the real frontier was never just out there. It was always within us, in our need to understand, in our refusal to stop asking questions, and in our relentless will to reach further.